Yeah.
Our brains now are in that class. The road,
Yeah, I always have like that. Yeah.
I know, I need to retape that again.
Well, at least this time we were
You're fine. You didn't do anything wrong. It's like that thing. Yeah.
I thought like something.
No.
Got so scared for a sec.
I'll be the one to
I did chicken.
say one thing. Fail.
Say
one thing. I failed.
if you ever
Right.
it's so hard to people
Why is there so much?
Oh, that's perfect. Oh,
exactly
I don't think that's the story exactly. I think we both know that's not exactly how the story is. No, I don't think. I don't know about that.
You what? Okay. Are you okay? Okay.
can I just eyeball it?
Are you on the Phi Theta one? Not really.
How you think?
It's about equal.
I don't know about that. Yeah, what do you think? So she wants a girl. I want to start. Great.
How does that? She said she's coming in by tomorrow.
There's like four.
I got an A on my retake. Did you do it too?
I can't use that anymore.
That's okay. Why did you this class? I was 3.0. Wait, how did my grade go up? What was it? Okay, 3.0. I don't know how. But that's okay. It's great. If I get an A on this paper, then we solid. Then we have a plus class. It overwrites all of the not so great things I have.
My writing isn't better than that.
Wait, I have a B plus class. Please, AP Lang gods be outside. Oh my god, I didn't know. Because I've been at a B minus all year. Because it was so freaking hard. I'm terrible at it.
Oh, that one? Oh, yeah, exactly.
My grades are slowly getting together.
I think my 89 grade is inching up, but my other grades are going down.
Same. Legit same.
Could be worse.
No, for real. And then we have a freaking 2-minute class. I'll have to take my year. Thursday.
No, what? No, stop.
It's like if I don't, then it's just
See, what do you think? I get even all of these because like this, like this, because the reviews are so high. You guys have to be like cumulative. Oh, that's terrible. I can't. It's so bad.
well,
That's true. If Andrew's getting an A, you're perfectly fine. He is? Ew. That's disgusting.
no, I'm just kidding.
All right, guys, let's go through this number 6 together. Guys, the 5 theta ones are the trickiest, so let's look at this one.
Wait, is it always going to be 0 plus 2 pi k over 5?
Yes. So you're always going to be adding 72 degrees. Yes. Yeah. You just need to find like the first point. No, it is not bad at all.
Not start at 0 and 90 degrees.
Well, we got to figure out where the first maximum is. Okay, guys. So when you're doing one of these with 5 theta, you want to think about where does sine reach the maximum petal length of 1? I know technically in this one it's 4, but then you divide by 4 and you're looking for the maximum value of 1. So where does sine actually equal 1? Pi over 2. So we have to then set this 5 theta equal to the pi over 2, and we can write plus our 2 pi k, so we remember what to add, and divide by 5. So where is my first maximum with this one? Pi over 10. Lovely. And we are adding 2 pi k over 5. Okay. I know it's labeled in radians and all of that, but pi over 10 is not on there. 2 pi over 5 is not on there. So I almost think the 5 theta ones are easier to do in degrees. Yeah, do we know what pi over 10 is in degrees? 18. So we have to start at 18 degrees. So realize this first tick mark is 15 degrees, and this one is 30 degrees. So it's just a little bit past the first tick mark, right? There's a little bit of eyeballing it here, guys. That's okay. Shove it in the middle. Pretty close. I'm going to go a little closer to that one. Okay.
Yeah, once you draw on it, no one can see it.
Yeah, it's true.
So.
And then, guys, I'm adding the spacing between, like, the tips of the petal here. It's 72 degrees that you are adding every time, okay? That's what 2 pi over 5 is 72 degrees. Well, what's 18 plus 72? That one works out nicely. So, 1, 2. Yep. I know 2 pi is 360, right? And then I just divided 360 by 5. That's all I did. Now, if you look at the spacing, do you guys see how it's 1, 2, 3, 4, almost 5 tick marks on this circle? Just start counting around from there. So I'm going to go 1, 2, 3, 4, almost 5. 1, 2, 3, 4, almost 5. 1, 2, 3, 4. How far am I on this last one? Somewhere in there. That looks too close. You can also check from the other direction. Because if I go the other way, 1, 2, 3, 4, yeah, it's right in there. You can see how it's literally just like about there, about there, about there. If you get to the end and you're like, you have these 2 dots, like, do you guys see right there the spacing's off? Yeah, look at your graph if you're like, oh, that's weird, those are too close together. Then just move them so they're not too close together, okay? So let's see, where was I? So like right in there. And then 0 to pi, again, yes, that's only half of the unit circle, but remember when it's an odd number of petals, it's really 10 petals, but just 5 distinct petals. So we still see the whole thing, okay? So I'm probably not going to do this in the right order here, but try. Did you have like spirograph flashbacks while drawing?
But it's a spiral.
Spirograph? Do you remember the spirograph? Do you know what that is?
We got half one. I'll bring it in. We can all play
Okay,
with it.
yeah, it's like this circle thing with a smaller circle, and you put your pencil in the middle, and you go around the circle.
And then when you
and
accidentally mess it up, you're
It's so
like
disappointing.
towards the end, and you're like, oh, I have to restart the whole thing. It's bad. That was
Is it okay if Riley
Like the pi over 2 one should be on the pi over 2 because that one we can actually figure out exactly what it is. And pi over 10, just make sure, like if you have your first petal like at 30 degrees or more, that's not quite right. Okay, you need to be in between the pi over 6 and what would be pi over 12. Okay, so not looking for perfection, but like
Not looking for mediocrity.
not totally off either. Okay, somewhere in between. Did you guys have questions on others? Are we feeling?
will we be in unit where we can graph these on a calculator?
No,
It's harder.
no.
Why does he want to do it?
Are you guys okay with all the rest that are the 2 theta and the 4 or 3 theta?
probably 5.
Yeah, so let's do one that's not 5 theta because that's 5 theta is not real fun. Let's do number 7 here, and then 8. Did you have a question about that one?
Graph that from 0 to pi over 2.
Yes. So you want to then actually, you don't have to like plug in everything, but think about when theta 0, what do you get?
Bro, I just actually I'm really excited to see back.
No, you get sine of 0.
I just want to know where I need to improve.
What's the sine
My
of
goal is
0?
not to get an A on this. My goal is to see where I fucked up and spend my time
Yes. So
fixing that.
you get 0? Okay, so your first point would be, we'll switch colors here, would be at the pole, right?
No, wait, what? Oh.
And then if I kind of think my way through, it's hard with the 5 theta because you're like, well, what would I plug
I'm
in?
most of getting a C.
I guess I could plug in pi over 10. Because what's 5 times pi over 10?
C for
Pi over 2. Yeah, so you can like
so funny.
work your way through and then you get here. But it's, I won't give you a weird window with a 5 theta. Okay? Let's look at like 3 sine 3 theta here and do that one with a different.
Wait, so like, are we gonna have to like worry about any questions for like that one?
Like a 5 theta?
Yeah.
You might have to graph a 5 theta. Yeah.
Like, and convert it to degrees and all that.
Well, it's always 72 degrees. Like that doesn't change. Because 360 divided by 5 is always that. So if we look at number 7 here, so 3 sine of 3 theta, I know that like the petals where they are with sine, it's not symmetric to the x-axis, it's symmetric to the y-axis. Tegan, are you with me? So let's think through a few values here. If I start at 0, what do I get? Yeah, 0, 0. Let's go, we'll do pi over 6. What do I get there? 3, because that is pi over 2, yes. Like, what did I give you? What about pi over 3? What do I get? 0. And then let's do pi over 2. So like, let's pretend our window here was just pi over 2. No.
Oh, wait, negative.
-3. Okay. So if I start 0, 0, and then 3 pi over 6, back to 0, and then negative 3 pi over 2. So Tegan, do you see, if I start at 0, 0, I come out to pi over 6, and then I come down? Did that order make sense? Okay. If I was graphing the whole thing, then it would also continue, you know, over there. But it's just that much of it if I only do the numbers.
Are you gonna give us any other restrictions like
Probably not. Pi over 2 would probably be the smallest that I'd give you. I'm just trying to think, like, on a circle I might, right, or, you know, a limson I might give you kind of a weird window, but.
what if you had to keep it odd number, like an even, like 6, like 2 pi instead of like that one.
Yeah.
So you were doing pi over 2. No, yeah, pi over 2, like a deep quarter.
Yeah, so I'd only see one pedal then, right?
Yeah.
Okay. Because this should have 4 pedals total.
Yes.
No. It's just whatever the coefficient is on theta, you double. Yeah, when it's even. I mean, you technically double it when it's odd. It's just not different.
For my Abba. I tried not hotter than that.
I changed that one to pi over 2.
Where you
So if you're graphing over a window where you're only going to see part of it, like if I'm going 0 to pi over 2, I have to start when theta is 0, which is at the pole.
I love the format. The issue is that so we need to there's only one like counterclaim for my thing.
Yeah.
It is so ass.
So like on number 8 here, if I change this window to pi over 2, make it real weird. You just need to figure out which, like, one pedal essentially you're graphing. So if I put a 0 in, what do I get? Hey guys, up here. Rohit, you asked about this one, right? So if I put a 0 in, what do I get? A 0 in for theta, what do I get? For R. 3?
Like all will do to not just like
2 times 0 is still 0. Cosine of 0 is 1. 1 times 3 is 3. Yes, we're just plugging in theta values. Let's see. I could do pi over 4. We'll just do a few of these. What do I get when I plug pi over 4 in? Pi over 2. So I could have radius of 0, that doesn't matter, and then negative 3. So you technically see half of this pedal and half of that pedal. Does that make sense?
Yeah. And that's a 4.
Yeah. Yes. And that's technically one pedal.
It's 2 pi. Half of it is pi.
That's not that bad.
That doesn't look pretty.
yeah.
It does not look pretty because it's
You got me
closer.
right.
So you only get
Yeah.
half pedal and a
Yeah.
half.
Thanks, bro.
All right. Are we okay on roses, guys? Sure. Sounds super sure on that.
Yeah, can you tell the confidence?
Yes. All right. We are going to do some writing equations. Hold on. Let me find where it is. All right. So we pass out. Oh, and I told you to check your That should pass it.
Yo.
And then I spotted a solution with like education.
Yo. Yeah. Yeah, that's fine, bro. I just feel like in the whole team, obviously, you know, it's an 80 guy, you're like,
On like sustainability as well. Oh,
I know there's like 3, 4, 5 seconds.
I just need to write it out.
That could be negative.
All right, guys, let me pull this up here.
Mr. Lee, what happened to this? It's like 16 petals.
Okay, I bet you could write the equation of it then.
Would you force us over to draw 16 petals?
No, I won't make you graph that. There you go.
Nah, man, there's no way you run this stuff from the floor. I was thinking just roses.
Yeah, not just roses.
It will be pizza. Oh. My short-term memory doesn't remember that.
Sorry, guys, I'm trying to get this up here for us. Okay, here we go.
I'm scared.
Okay, guys, so this worksheet is kind of hard notes, kind of your homework, all combined into one thing. We're just going to practice all of these. So you can see it's not just equations of roses, okay? It's everything we've done so far. So, nope, we have lemniscates and spirals left.
Can they please try
Yes,
to do
lemon biscuits.
Lemon biscuits?
I'm kidding, just lemniscates. I just think they sound like lemon biscuits.
Lemon biscuits? No, I guess what?
Now you want some lemon biscuits on
Okay,
Thursday?
we can do that.
We can maybe do that, yeah.
So wait, what actually is it?
It looks like,
No, like, how's
I don't know.
oh, lemniscates. They
So
kind of
it's
look
not
like,
lemon biscuits?
no,
Oh, okay.
that just helps you say it, yeah.
Yeah, honestly, you could bring those out.
I know. Okay, guys. So, what I want you to try to do right now, use your notes, use your neighbors, work together on this. Let's try to do the first 4. Okay? When you write an equation, what does it have to start with? R equals R. Sure.
All right.
Yeah, Rohit. Oh my god.
Wow, that's so cute, Mr. Lee.
I know, I do.
R
Yo,
equals 3?
that's the
Sine.
product of
Wait,
the
it goes on.
And it's even, look, it's like a Madison one.
I didn't know they did that.
Yeah.
Why don't we get these?
I don't know. It's like a teacher appreciation thing. It had like the little, it's like you don't drink the fruit when you drink it. It's got like the little filter thing. Yeah. We were worried, Adam. Yes, that's what we were worried about. It's Adam.
This is one of the smallest campuses.
Right now,
Special gift. Adam, we're writing equations, okay?
Oh, it's so chilly. Wait, what?
I don't know. I know that obviously, but they would get to the West. I don't know how like climate sense. I know I wrote that stuff, right? Oh, thanks.
Wait, it's like,
Mhm.
Okay.
Wait, it's the last, right? It's the last bit.
No, we still have lemon biscuits.
Is that next year?
On Thursday, I'll teach you lemniscats and spirals. The
Biscuits.
spiral of Archimedes. Kids love that.
Yeah.
Lemon biscuits sound fun.
How many kids do you have? Like,
28.
I love learning how to ask stuff. I'm terrible.
Lemon poppy seed stuff. Oh, I've never had those. Ooh, okay. I'll try that.
What in the world?
Why are there so many things?
That's what, like this unit or skill, whatever, none of it is that hard on its own, but it's putting it all together. Your brain is like, sort it out, so.
Now I have all these those away. I have a B plus in that class, and I'm at the point away. A minus 10 because stupid D in a stupid 60.
Wait until you get to the unit. I got an A, B, C.
Honestly, yeah, right. School's hard. I didn't sign up for that.
I think you did. I think you picked your classes.
I picked my classes, but not school. I didn't pick school. This is required by law.
That's
I wish I didn't take this, and then I made my next year school. Under like 518. I'm like, why am I doing this to myself? What am I doing?
how are we doing, guys?
Watch a lot of anime recently. Just even started the original.
I don't know how to graph this. Is your have the not total is 5. The difference is 2.
Now you gotta figure out which one's gonna win. Because it matters. Yeah.
Oh, it's 1 and 3.
We'll just keep
Number 1? Yeah, 1 and 3. So I thought it was 5. Oh no, I don't remember.
How do we decide which one?
Yep. Doing the thing. Yeah, so it's not. Oh wait, no, this is
So write it one way. Kind of weird.
oh no.
Yeah.
So how did you get 1+7? No, I don't know.
It's like that thing in biology, like where the cell is like.
Yeah, like we're so
How did you get 1+7?
you're writing things that you have
It's like, dude, I've seen so many like that's like.
Oh, I think you're different. I don't think it's this. A lot of people don't remember.
And let me put the answers up for the front here.
Wait, no, this is right.
All right, guys. Number 1. Your 4-petaled rose here. What did you write as your equation? Yes. Yes. All right, guys. Are we okay with that one being 3 cosine 2 theta? Yeah. Okay. Number 2. These are the trickiest ones, I think, for you guys to remember what to do where. What did you get for your equation here?
I got the wrong answer, so it's not.
3 plus 4 cosine theta.
Good.
Oh, I see. Because that equals the diameter of the hole.
Yeah, guys, how far out does this go? 7. And then what is the length of this little inner loop? 1. So you need 2 numbers that the sum is 7 and the difference is 1. Okay? So that's how we came up with the 3. It cannot, because the difference between that is not 1. You'd have like a really long inner loop. Yes. That was not a good I think we're okay. All right, guys, your circle here. Did we get r equals 4 sine of theta? Yes? And r equals 4? We like the circles, right? Yeah.
We remember it.
Yeah, I love circles. What?
Circles are your least favorite. Yeah, that's not today.
It's like one of those old
They're like the same thing.
Okay. All right, guys. Number 5. What did you get as your equation here? Okay, guys, I can't hear. Quiet down, guys. Ethan. Rohit. Guys, what'd you get? Say it again, Shane.
R equals 2 over sine theta.
Okay, that would work.
What is our sine theta?
Or 2 cosecant theta. Yeah, you want to get it to r equals. So you are right if you said r sine theta equals 2, but you have to solve for r.
That's so dumb.
Yes, I would take 2 over sine of theta. Yep. And let's do the last one on the front here. What did we get there?
R equals 4 sine 3.
Yes.
Oh yeah. Why don't the roses have not
Okay. We like roses. The one day I was gone. What does that say?
We're so late. Doesn't mean we don't like you.
No, I know. Roses make sense. Like, it's easy to see those patterns. It's easier than the leaves. All right. Do you need another minute for the back? Okay. 7 and 9. Okay.
Yeah. Wait.
Guys, on 7, do you see how it's now on the left side? So there's got to be a negative in there. So how far out does this go? Okay, and then how long is this? 2. So we can say 1 minus 3 cosine theta. There are other ways you can like mess with the negatives, and you can check it on your calculator here, but this will work to get it on the left side over there. It's kind of interesting how those work with the negatives.
What would it look like if you did negative 1 plus 3?
Let me show you. So you'd be back on the right.
Wait, and actually, 1 and 3 are 2 again.
So 2 numbers that add up to 4, and the difference between them is 2.
But what does negative 1 do?
Not a lot, but if you take it out and put the negative here, now you've switched which side it goes. Yeah, it's sort of interesting. I almost think of it as like, I need more negative to actually get it to the left side. Like the 1 isn't enough negative. Like that's not really what's happening, but like that's how I remember it. So, yes.
But 1 and like negative 3 don't add equal.
Say it again.
You gotta add.
No, but you just look at the A and the B value, not the sign in between them.
But how do you know to put this on?
Well, you know it's going to the left.
Oh, so you just put that as the side.
Yes, I wanted to show you this one too.
Because it usually goes to the right.
Guys, this also works if you make the 1 negative. So negative 1 minus 3 cosine theta. Also, same graph over to the left. So there are multiple ways you can write this.
Put negative everywhere.
That will work, yes.
Great. Okay.
Like a sine one, if it's down, make them both negative. Yeah. Okay, David.
4 and 2 is 2. Like, I get the 1 value, but I can't get how to get the 2.
Okay, so I need 2 numbers that add up to 4, and the difference between them, you can't really tell that that's 2. The difference is 2.
Oh.
So 1 plus 3 is 4,
Oh,
right?
added difference?
And 3 minus 1 is 2.
Okay.
Yeah. Does that make sense? Okay. So again, another option here, you could, oops. Maybe. Sorry, my pen stopped cooperating.
Joy.
Okay, well, okay. Too far. You could also, does not like me today. All right, so either of those would work. Yeah, okay. All right, do you guys have an answer for number 8?
Yeah, R equals 3 over
Yep, that works. Or I would take 3 secant theta.
Wait,
That's more complicated.
Wait, would you not take R cosine theta equals 3?
You want to solve for R. You're one tiny step away, okay? All right, do we have an answer? 2 plus 2 cosine theta, I like it.
How do you calculate that basically?
How do I what? I'm sorry.
Calculate that.
So on the cardioid heart ones, where does it cross the axis there? No, here. 2, and then, yeah, so and remember with a cardioid, if it touches at the pole, you know those A and B values have to be the same. You can also look like out here is a 4. So it's the same idea. I mean, really, it's the same idea as the inner loop. They have to add up to 4, and the difference has to be 0, because your inner loop length is 0, if you look at it that way. I know it's not an inner loop, it's cardioid, but.
I never thought about it.
Okay. It does. Okay, guys. Did we get an equation for number 10? Yes, R equals 3 sine 8 theta. Okay. All right, 11 and 12, obviously you don't know what's happening there yet. So it could not be cosine. So guys, the difference when it's an even number of petals, sine and cosine are both symmetric to the x and y axis when it's even. Do you see how none of the petals are actually on the axes? Okay, that's your indicator that we're looking at a sine one. Like if it only has 4 petals, this is a cosine when it's like this. And the sine one is here, here, here.
Is sine never on the axis?
I mean, not when there's even. When there's odd numbers, you can have one on the axis, but that's sort of your indication. Like if it lines up on the axis, it's cosine. If it's like rotated slightly, it's sine. Does that help on 10? Was that the part you were stuck on? Like why is it sine and not cosine? Okay. Okay, guys. So I know Adam, you were gone last time. Was anybody else gone last time? No? Okay. I need to give you a copy of the homework worksheet. Guys, that's essentially the end of your notes there. So, and the end of your homework worksheet. I planned that. I was like, so, if you haven't completed the worksheets for 9.3 and 9.4, you should do that. If you need an extra copy of that, let me know. I will post second attempts for 9.1 and 9.2 on MathSpace for you right now as well. Okay? You have a question?
Wait, we're back. we apologize. You yelled at me.
Oh, I thought you were your essay.
Well,
Just one round.
Yes.
Okay, let's put.
You're so smart.
I'm stealing.
Oh yeah.